Hello students, welcome back to today's class. So today we'll be talking about the topics of thermodynamics as I have sent you some of the notes of some of the topics which are there in the thermodynamics. So better that we may do the explanation of the topics which are already sent to you. So here in lecture 1 you may see, I hope that everyone has written all the topics which have been mentioned here, the PDFs which has been sent to you. Okay, so there may be some of the things that you may not understand, so just because of that I'm making this video so that you may understand the things which I made you to write. So here, starting this lecture, that is the lecture number 1, here you can see on the top the thermodynamics. Okay, so basically if I'm defining thermodynamics, so we can say that it's a branch of the science, or we can say that it deals with the interaction of the heat and other forms of energy. So as I already told you, as we have studied in that previous chapter also, that was the thermal properties of matter, that the temperature of different objects which are there in the natures are different. So what happens, there is a property of the heat that it always flows from the body which is at high temperature to the body which is at lower temperature. So that what we can define the thermodynamics. So it is written here, it deals with the study of interaction between heat and other forms of energy. Now next we may come across the thermodynamical system. Okay, so basically the system can be assumed that can be there be the collection of large number of the molecules which are there. Okay, so everything which is there in the nature has been made up by number of the molecules, or one can say is a matter. It can be solid, it can be liquid, or it can be a gas. So basically in this thermodynamics, in this chapter we'll be studying about the gases. Mainly we have to study about the gases. So there are some of the parameters which decide the stability of the, one can say, the system, and the parameters are the pressure, volume, temperature, and internal energy. Here you can see, I think, okay, here the things are there. Here in the second line of the thermodynamical system, or in the second paragraph of the thermodynamical system, it is written there, the parameter like pressure, volume, temperature, and internal energy, etc., which determines the state or the condition of the system are termed as thermodynamical variables. So that what I'm saying here, there are some of the variables which decide the state of the system. Okay, so these are termed as pressure, volume, temperature, and internal energy, and there are many other. Okay, so next we talk about whether the system which we are having, on which the study is based, is in thermal equilibrium or not. Okay, so first we shall understand that what is the thermal equilibrium. So thermal equilibrium basically is related to the temperature fact. Okay, so first we shall understand the concept of temperature, that what is temperature. So temperature of a body is the measure of its hotness or coldness, like that what we define the temperature. Okay, so when shall we say that there is no thermal equilibrium? So the other fact and or the other phase should also be known by us. ओके, सो कब हम कह सकते हैं कि हमारा जो सिस्टम है, दैट इज़, और वन कैन से इन केस ऑफ थर्मल इक्विलिब्रियम वी talk at least about two systems which are there. Okay, they may be in thermal, they may be in contact, or they may be touching each other. So what happened, obviously we understand in this nature that it is not necessary that initially the temperature of both the bodies, or one can say both the system, may be same. There may be some variation in the temperature. Okay, and I have defined already that what is temperature. Okay, so obviously what will happen, the bodies which are the two bodies which are touching each other will, what, there will be the transfer of heat among them. Okay, so it will be what, flowing from the body which is at high temperature to the body which is at lower temperature. So after some time what will happen, after some time what will happen, the temperature of both the body will become what, same. Okay, that means there is no exchange of heat in between them, and when they are placed in contact with one another. Okay, so such condition, when the body, when the two bodies has reached, is known as the condition of thermal equilibrium. Okay, so that means how we define the thermal equilibrium, ki when there is the no exchange of heat in between them. Okay, then we can say that both the bodies are in thermal equilibrium. So here again we define there are some of the variables which do not changes with time, that is the pressure, volume and temperature and mass, etc. Here you it is written in the bracket, you can see P, V, T, comma M, etc. Okay, they do not change in case of thermal equilibrium. Okay, so further, after knowing about this thermal equilibrium, we talk about zeroth law of thermodynamics. There are some laws which are there for thermodynamics. That is the zeroth law, first law of thermodynamics, second law of thermodynamics. Okay, that is there in the syllabus that we have to talk about. Okay, so here in this case, we start with the first zeroth law of thermodynamics, and it states that here we consider at least three systems. Okay, so I may share the screen. Let me go to the camera. So here you may see the register. Here you may consider three systems like this. So here we may consider three systems that you can see here, and these are separated by some walls which are there. So here you can see that system A is there, B is there, and system C is there. Okay, so here you can see that A and B are separated by insulated wall. Okay, and A, C, and C and B. Okay, so if I consider A and C, so there is the wall which is supposed to be conducting. Similarly, the system B and C are also separated by a conducting wall. That means there can be some exchange of heat if there is some temperature difference. Okay, so here, but in this case there is no exchange of heat because the wall is completely what, insulated. Okay, so now what I mean to say, that it is said that according to zeroth law of thermodynamics, as it is written there in the notes that I have already provided you. Okay, so it says that key there are systems. Okay, so if I consider the systems as such that A and C, okay, and B and C are in thermal equilibrium, so what I shall write here, I may write that temperature at A will be equal to temperature at of C. Okay, similarly I may write that temperature of B will be equal to temperature of C. Okay, so this is the condition just because of this conducting wall which is there, but we cannot say for this. Okay, but according to the given arrangement and according to the law of thermodynamics, it says that ki after some time what will happen, this Ta, that is temperature of A, will also become equal to the temperature of B. So this what the thermodynamic, or one can say the zeroth law states, okay, of thermodynamics. Okay, so now let's come back to the PDF which we are having. Okay, and let's see that what is zeroth law. That is same that what I already explained. So zeroth law of thermodynamics states that when the thermodynamical system A and B are separately in thermal equilibrium with a third system C, that what I have drawn here. Okay, then the system A and B are also in thermal equilibrium. So the same which I explained is written here. Okay, so this is a zeroth law of thermodynamics. Okay, so that condition is very important which I have written there, that is Ta is equals to Tc, and if Tb is equal to Tc, then after some time what will happen, Ta will be equal to Tb. That means the temperature will be what, same of all the system after some time. Okay, under the given condition. Okay, so there are now some of the facts, or there are some of the, one can say, thermodynamical state variable about which we have to discuss. Okay, so now further we discuss about the heat, work and internal energy. So we already know that what is heat is nothing but energy, and most of the time the work is done sometimes by the heat or the energy which is supplied to the system. Okay, so about that we will discuss later on, but before that we shall know about the term that is internal energy, that is the state function. Okay, so why is it state function, that will also be discussed here. Okay, so here you may see that internal energy is nothing but it is very similar to the energy terms that we have already studied in that mechanical system. Okay, so here internal energy basically comprise here we suppose that here we are talking about the gases only. Okay, so internal energy comprise of both the kinetic energy as well as potential energy. Okay, this you shall understand. Okay, so but in case of real gas it is what applicable, but in case if I talk about the ideal gas, so ideal gas we better know that the intermolecular attraction in between the molecules is supposed to be negligible. So if the intermolecular interaction in between the molecules are supposed to be negligible, so we cannot say that the potential energy term is considered to be there. Okay, so the thing which will be there will be the kinetic energy of the molecule. Okay, so that how we define the internal energy. So if I am talking about the internal energy of the system, so it is said that the total internal energy of an ideal gas is entirely the kinetic energy of the molecules. Okay, in case of what ideal gas. Okay, so that what it is written here also in some other words that I hope that you have noted it down. Okay, so internal energy refers to the energy possessed by the system because of the molecular kinetic energy. See here it is written. Okay, and molecular potential energy. So why I neglected the potential energy, that you better know. Okay, so further here it is written that for an ideal gas it is written. Okay, you may see in the last line of this page that internal energy is depend upon the state. Okay, and thus it is a state variable. In case of the real gases, internal energy is only by virtue of the molecule motion, whereas for an ideal gas it is mathematically given by U is equals to N into F into R into T by 2. Okay, now we need to understand that from where this formula has come. Okay, so now let's come back to the camera. Now let's talk about that internal energy factor. Okay, so internal energy basically comprises just because of the, one can say, the kinetic energy of the molecule which are there. Okay, that I already explained. So there is the law that is known as law of equipartition of energy. Okay, that we have to discuss in kinetic theory of gases. So there's a very small description about that, only a small statement that will be considered here. That is, according to the law of equipartition of energy, the average kinetic energy per molecule of an ideal gas at absolute temperature capital T is said to be, okay, average kinetic energy at absolute temperature, this is the sign of average, okay, is given by per molecule, it is written there. Okay, average kinetic energy per molecule of an ideal gas at absolute temperature capital T is equals to how much, this you shall know. Okay, that is half F into K, that is the Boltzmann constant, and T, that is the absolute temperature. This you shall know according to equipartition of energy, law of equipartition of energy. Okay, and after that if I consider 1 mole of the gas, okay, if I consider 1 mole of the gas, so for 1 mole I better know that the total number of the molecules are how much, Na, that is the Avogadro number, and the value you better know about the Avogadro number. Okay, so for 1 mole of the gas, what will be the value of that? This is what, this is the U, that is the internal energy. Okay, excuse me. So for 1 mole of the gas, okay, so U will be equal to how much? U will be equal to, here we have, what we have to do, here we have to just multiply by the factor n. Okay, that is capital N, that is the Avogadro number. Okay, क्योंकि अगर if I talk about per molecule, अगर एक molecule के लिए इतना होता है, so if for capital N, any number of molecules, how much it will be? This much only, that is F into K, that is into T. Okay, so KB इसको अप्लाई कर दे, सफिक्स में B लगा दिया जाए, that is the Boltzmann constant. Okay, that has a specific value. So this is the value for what I can say, this is the value of the internal energy. Okay, and there is one more fact that you shall know. If I multiply this Na with this K, so that gives another value that is known as the R, that is universal gas constant. Okay, तो ये क्या होता है हमारा, N into K क्या होता है हमारा, R होता है, that is the universal gas constant, and this value is fixed. Okay, universally. Okay, so this is the value of the internal energy. Okay, so for how many number of molecules, for Na number of the molecule, that is 6.02 into 10 to the power 24. Okay, so further if I talk about for n number of the moles, ठीक है, अगर हमारे पास ये तो एक मोल के लिए हमने बात किया था, दिस वी हैव टॉक्ड अबाउट वन मोल. सो इफ आई टॉक्ड अबाउट n number of the moles, okay, so for small n number of moles, so internal energy will be how much? Internal energy will be that n will be multiplied here. Okay, so n into half so u will be equal to small n, that is the number of moles, okay, into half into f into r into t. Okay, so this what has been written in there in the PDF in the direct form. So from where it has come, that I already explained you. Okay, so let's come back to that PDF. So now you may see that the internal energy U is equals to N into F into R into T by 2. It is written here. Okay, I hope that it is understood to you. So now further, here it is written where N is the number of moles, F is degree of freedom, R is universal gas constant, T is temperature in Kelvin. Okay, now let's talk about the work. Okay, rest of the thing is a normal thing that you may understand, okay, by reading. So I'm not going to read line by line. Okay, it will be not be good for me also. Okay, so now let's talk about further, let's talk about the work which is done. Okay, so here it is written there on the heading heat, work and internal energy. So concept of internal energy is over. Okay, now we further proceed to the work. So whenever we know that whenever we heat gas, suppose, okay, for example, so what happens, it expands. Okay, it expands and there will be some change in the volume. So here you can see the figure is drawn. Okay, here the figure is drawn there. Okay, so here gas force is there which is applied by the system. Okay, here you may see the direction of the force on the piston. This is the piston. This is the piston which is there. Okay, so the force is applied from this side on the right side of the piston, and the piston has been moved to this point. Okay, this point the piston has been moved. Okay, so here you may see the dotted lines which are there now. So this is the final position of the piston, and this is the distance, which is dx is the distance that has been moved by the piston, and here the gas is doing work. Okay, so basically we know that work is what? Force into displacement. So if displacement is dx, force is F in terms of pressure and area. Okay, P dot A is written there na. Okay, you may see that here the P dot A is given there, F is equals to P dot A. Okay, so this is the normal relation in between the pressure and the force. Okay, and this is the cross sectional area of that piston which is there. Okay, जो कोई भी piston होगा तो उसका क्या होता है, एक एरिया होता है जिसपे हमारा क्या कर रहा होगा, प्रेशर एक्सर्ट कर रहा होगा इसके अंदर जो गैस भरी है. ओके, सो व्हाट विल बी द वर्क डन, since it is a continuous process, you can see continuously the piston is what moving, not all of a sudden it has reached to this point. Okay, so it not all of a sudden it has covered that distance dx. Okay, so here what the work done formula is there. F is what, देखो जो ये dx लेंथ है ये ऑल ऑफ अ सडन तो आया नहीं होगा. ओके, देयर वुड बी सम इनफाइनेटली स्मॉल डिस्प्लेसमेंट. ठीक है, थोड़ा थोड़ा डिस्प्लेस करके ही क्या हुआ होगा, इस पोजीशन तक हमारा क्या हुआ होगा, पिस्टन पहुंचा होगा. ओके, सो that what we have to do, the small work done gives the whole work done which is there, that I explained you many times in the class also. Okay, so the same thing it has been done here, that is integral of small work done, that is F into dx. Okay, is done here to obtain the total work done, that is the W. Okay, over the required displacement. Okay, so this is equals to integral of A into dx, that is P into dV. Okay, now further here is a normal thing which is written there, the P is the pressure of the system, pressure of the system on the piston. Okay, so now we need to understand that there is some sign convention which is given to that work also. Okay, that sometimes the work can be positive also, sometimes the work is negative also. This is what is written here, this work done by the system is positive when the system is expanding and negative when the system is contracting. Yani ki if there will be some compression here, so in that case the volume will be decreased and work will be said to be negative, otherwise it will be what, positive in case of expansion. Okay, further This is the normal thing that you might have studied in chemistry also. So this is the ideal gas equation that you can see, PV is equals to nRT. Okay, now further we talk about the thermodynamical process. That is the main thing of the heart of the thermodynamics. Okay, so here it is said that you can understand that if any work is done on the system, or if any work is done by the system, or if any study is going on the system, so it may be done under different circumstances, or one can say under different condition. Okay, so based upon that, there can be some change in that parameters, or one can say the variables which are there: pressure, volume, temperature, and number of moles, one can say. Okay, so based upon that, we study here about the thermodynamical process. Okay, that means the process which is the change which is carried on any system, or which is carried by the system, can be classified into the following types: that is the isothermal, adiabatic, isobaric, isochoric. Okay, this is written here based upon this diagram, that is P versus V. Okay, this is the graph, this is a normal graph which is drawn there, or one can say the two axes are there. So here in case of isobaric, we need to understand if the any change is brought about there in the system, or one can say if any change is brought about in the state of the system, that is there is a change in P, V, or T, like that. Okay, so it can be done by these following ways. Okay, that is the isobaric condition can be there, isothermal can be there, adiabatic can be there, or isochoric can be there. Okay, so here you can see that isobaric is that thing under which the pressure is supposed to be what, constant. So here you can see that in case of isobaric, when the pressure is constant, so in this PV diagram you can see that a straight line is there, the above one. Okay, the two curves are there, है and two straight lines are there. So the above straight line, which is horizontal to that V axis, you may see that it is the giving about the it is giving about the nature, or one can say the curve that is obtained by the study under the isobaric condition when the pressure is constant. That means there is some change in the volume, but the pressure remains what, constant here. Okay, similarly for isothermal condition, that is isothermal stands for constant temperature. So if any change is brought about in the system at constant temperature, so the condition is said to be, or one can say the process is said to be what, isothermal. Okay, so here B and C, here the curve B which you can see tells about the isothermal process. Okay, the system has been changed from one end of that curve to the other end of the curve. It has been brought, okay, from one end of the curve to the other end of the curve. Now we come across the adiabatic. So in case of adiabatic, Q remains constant. That means there is the there is the net exchange of heat is what, zero, in between the system and in between the surrounding. Okay, if I consider, so for that the curve C is drawn there. Okay, and then the last one is the isochoric condition which is there. Okay, that means if I talk about the change in the thermodynamical state at constant volume. Okay, so here you can see that the on this volume curve, if I consider, so there is the straight line which is drawn by the, which is shown by the D alphabet which is there now. So here you can see that no matter the pressure is changed. Okay, so here we have to consider the state of the system to be at the ends of the line. Okay, the system might be at the upper end and it has been brought to the lower point of that line. Okay, so here this is the condition, or one can say the line which is showing the condition of isochoric. Okay, that means the change from one end of the line, the system has been brought to the other end of the line, and during that procedure, what is there, the volume is not changing but the pressure is changing. So you can see that the upper point of the line, if I'm talking about this D line, the upper point of the line, the pressure is more. At the lower point of the line, the pressure, if I match it with the pressure axis, so the pressure is what, less. Okay, so this is the condition of isochoric. So related to that, I have already sent you one PDF, okay, in which the detailed explanation of the of all the processes has been explained to you. In this, internal energy is also there. Okay, the second PDF, that is the lecture 2 which is written. So here everything has been explained to you. Okay, so further, the if I talk further about the first law of thermodynamics, So based on that only, the all the processes, isobaric process and isothermal processes, and everything has been discussed, and the work done, the proper expression of the work done has been calculated here. Okay. So let's be systematic, and let's come back to that PDF. Okay, so let's come back to this PDF. So basically what I mean to say, if all the process if I come across, so अगर मान लो ये line है, this is the line A, this is the line D. Okay, so not all of a sudden the state of the particle has reached from this point, from one end of this line to this end of this line. Okay, so there may be small processes, or one can say infinitesimally small processes, which will be going on throughout this line to complete the required process. Okay, so based upon this we have to talk about that what is quasi-static process. Okay, quasi-static process is what here it is written, that it's a thermodynamical process that is infinitesimally slow एंड इज टर्म्ड एज क्वाजी स्टैटिक प्रोसेस. ओके, यानी कि बहुत स्लो चेंज होता है किसी भी प्रोसेस को होने के लिए, चाहे वो हमारा आइसोबारिक हो, आइसोथर्मल हो, एडियाबैटिक हो, या फिर इट कैन बी व्हाट आइसो one can say choric process. Okay, so what I mean to say is here is that quasi static process is what in that the system what changes very slowly, or one can say at very slow speed what it changes its state at every instant. It is written there. Okay, at every instant, yani ki suppose that this is a large line which is there na, a line is the large line, so it is made up of different points. Okay, so if I take the two consecutive points, so the from one point to another point only the system might be moving to complete this entire line. Okay, so all the this line is made up by different number of the points. Okay, so starting from this point it may move to the next point which is there, which is joining that point, and then it further moves to the neighboring point like that, and by making all the points like this it may have come to an end to complete this line. Okay, so at every point what I mean to say, there is the slight change in the thermodynamical variables, that is the pressure and volume, one can say. Okay, but in that case suppose that there are some 2 points which are there, which are in contact with one another along this line only. So at these 2 points there will be slight change in the thermodynamical state, but still in case of quasi-static process it is said that the system is, if I consider these 2 points, the system is considered to be in thermal as well as in mechanical equilibrium. यानी कि हमारे लाइन जिस 2 पॉइंट से या फिर हमारे न्यूमरस नंबर ऑफ पॉइंट से वो करके जो बनी हुई है, तो अगर हम किसी एक पॉइंट को लेते हैं उस पर हमारा कोई थर्मोडाइनमिकल स्टेट होगा, दैट इज़ प्रेशर, वॉल्यूम एंड टेम्परेचर हमारे सिस्टम का, उसका जो नेक्स्ट पॉइंट है उससे सटे हुए, ठीक है, अगर हम प्रोसीड कर रहे हैं एक लाइन को बनाने के लिए बाय द हेल्प ऑफ दोज पॉइंट्स, ठीक है, उसका जो नेक्स्ट पॉइंट है उसमें स्लाइट चेंज होगा हमारा प्रेशर, वॉल्यूम और टेम्परेचर में, बट हमारे 2 पॉइंट्स को अगर हम कंसिडर करें और उस पर हम इक्विलिब्रियम के बारे में बात करें जो कि सटे हुए हैं, तो उन पे जो होगा हमारा सिस्टम क्या होगा, थर्मल इक्विलिब्रियम में पाया जाएगा, या फिर हम कह सकते हैं मैकेनिकल इक्विलिब्रियम में पाया जाएगा. तो वहीं यहाँ पे देखो इस चीज़ को लिखा है, द थिंग्स हैज़ बीन डिस्क्राइब्ड हियर. इन क्वाजी स्टैटिक प्रोसेस द सिस्टम अंडरगोज चेंज विद अ स्लो स्पीड सच दैट every instant the system is in both thermal and mechanical equilibrium with the surrounding. So every instant it is written there na, at every instant, that means the 2 points that are joining one another है ना, and we consider that line is made by different number of points which are joined with one another. So all the points which are there which are making that line are what deciding the state of the system which is there. Understood? So I hope that you may have understood this part, and rest is like this. Then we come across the first law of thermodynamics. So first law of thermodynamics is very easy. Okay, here you can see that there is a relation in between the heat supplied, that work done by the system, and the internal energy which is there. Okay, so what first law of thermodynamics says, that first law of thermodynamics said that कि energy can neither be created nor destroyed, it can only be transformed from one form to another form. Okay, and total amount of the heat energy which is applied to the system by the surrounding will be equal to the sum of the work done and the change in the internal energy. Obviously, if I am giving heat to the system, so what will happen, there will be some change in the internal, there will be some change in the kinetic energy of the gas molecule, and what will happen, the gas will what, expand. Okay, that means the work will be done, and we have already seen that it is what, work is a function of F into dx. Okay, so there will be some change in the volume. Okay, there will be some change in the volume. It is written that P into dv. ठीक है, ये कहाँ से आया है, वर्क इज व्हाट, इंटीग्रल ऑफ पी इंटू डी वी. दैट मीन्स डी इज व्हाट, द चेंज इन द, इट शोज अबाउट द चेंज ओवर वॉल्यूम. ओके. So here what will happen, if I am giving energy, so what will happen, that will what, results in the increase in the internal energy as well as the work that will can be done by the system. Okay, so this is the relation, which is very important relation of the change, the heat supplied with internal energy change and the work done. Okay, similarly there is some sign convention that you may see. It is normal that whenever the heat is supplied to the system, Q is taken to be positive. Okay, whenever heat is taken by the system, Q will be taken as negative. So this will be helpful in that numerical part. Okay, so this you shall know. So I hope that you may have understood this PDF part which I have sent to you. The lecture about the next PDF which I have sent will be given, okay, afterwards in the next video. So be tuned. Thank you.